Hey, it's Mr. Barr, and this is Graphing Functions, or Giraffing Functions. So, what are we doing? I can graph various types of functions. Graphs are all around me in the world. I want to be able to understand and create them. That's why we're doing this. The basic idea of 3D graphics is to turn a mathematical description of a world into a picture of what that world would look like to someone inside the world. The mathematical description could be in the form of a list. For instance, there is a box with a center 2, 4, 7, and sides of length 3. The color of the box is a bluish gray. To turn this into a picture, we also need to describe where the person is and what direction they are looking. For instance, there is a person at 10, 10, 10, looking directly at the center of the box. From this, we can construct what the world would look like to that person. Kind of confusing. Today we're going to turn a mathematical description, a function, into a graph. So at an incredibly simple level, what we're doing is using functions to create graphics. This is what video games do all day long. All right, so here's our first one, y equals x. So we're going to have a linear today, an absolute value today, a square root today, a cube root today, and we're not going to do a step function. So we got 4 functions that we're going to work through today. And let's start with our most basic one, the linear. So in our notes, we're going to go with our name, and our title today is Graphing Functions. And we have 4 types of functions that we're going to do today. One is going to be the linear, which I call a line. An absolute value, which is a v. A square root, that I call a half u on its side, half u on side. And then the cube root, which is the s. And let's put some of those guys in some quotes so it makes more sense. So the cube root is an S shape. This is a half u, a v. All right, so let's graph these, and we'll start with the linear. So I've got some graph paper right here. I'm going to take the notes on top, and then I'll graph it underneath. So we're doing a linear. The basic linear is y equals x. And if I made a table for y equals x, -1, 0, 1 would be -1, 0, 1. So the most basic line out there is y equals x, which is just a line that looks like this. And we've already done this using slope-intercept form, but this is the basic y equals x line. And when I start adding numbers to it or putting numbers in front of the x, it starts changing the line around. But this is the most fundamental basic line out there. Y equals x gives me that line. Our next one, and there it is. Our most basic y equals x line is right there. Our next one is the absolute value, and we've done absolute values before. And the most basic net for this is also -1, 0, 1. Absolute value of -1 is 1, 0, 1. Absolute values are not new to us. We have done absolute values. So when I plot that, I have -1, 1, I have 0, 0, and I have 1, 1, and I get my V shape And I'm so familiar with this graph that I can make these really easily without throwing out a big net. And that's the goal here, is to get so familiar with these graphs that you can just graph them even without a net. And there's our absolute value. Our next one is the square root function. And in its most basic form, it is y equals the square root of x. Now you're going to notice here, I'm going to throw out a new net. You haven't seen this net before. I'm going to go with things that I know the square root of. I know the square root of 0. I know the square root of 1, 4, and 9. I am throwing in numbers that are good square roots. Square root of 0, 0, 1, 2, and 3. Notice that I'm not throwing in any negatives. That's because I can't take the square root of a negative. You learned that when we did domain and range of functions a while ago. So I'm not even going negative, but that would give me 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, and 9, 4, 5, 6, 7, 8, 9, 3. Notice that it's kind of a curvy half U on its side. It's like a U, half of a U, but on its side. And our final one is the cube root function. Actually, look at this. There it is. Half U on its side. There's 1, 1. There's 4, 2. There's 5, 3. And our next one is the cube root function, which I call the S. And our basic function is y equals the cube root of x. For my net, I'm going to throw out cube roots. -8, -1, 0, 1, 8. A cube root, right? -2 times -2 times -2 is -8. So the cube root of -8 is -2. -1 times -1 times -1 is -1. So the cube root of -1 is -1. Cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, right? Because 2 times 2 times 2 is 8, so the cube root of 8 is 2. We graph that. -8, -2, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. -1, -1, 0, 0, 1, 1, and 2, 4, 6, 8, 2. You're going to notice this is kind of a curvy S shape. It's not going to be perfect. It's kind of an S. Yeah, that's why I call it kind of an S. What does it look like here? There it is. Notice we have -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And those, my wonderful people, are the 4 basic graphs that you need to know for my class. Later on, we'll learn about step functions, which are just lines that kind of go one direction and then stop and kind of do something else. We'll talk about steps on another day. Okay, that's it. Thank you for watching.